Hello everyone, and welcome. Today, we are going to demystify a very important term in UV visible spectroscopy, lambda max, often written as max. Before we define it, let's quickly remember what UV spectroscopy does. It shines light of different wavelengths through a sample and measures how much light the sample absorbs. The result is a graph called a spectrum, which plots the amount of light absorbed on the vertical axis against the wavelength of light on the horizontal axis. This graph usually shows one or more peaks, looking like little hills. So, what exactly is lambda max? It's simple. Lambda max is the specific wavelength at which a substance absorbs the maximum amount of light. It is literally the wavelength corresponding to the very top of the highest peak on the absorption spectrum. The Greek letter lambda is the symbol for wavelength, and max just means maximum. So, it's the wavelength of maximum absorbance. But why do we care so much about this one specific point? Lambda max is incredibly important for two main reasons. First, for qualitative analysis, which means identifying a substance. Many compounds have a unique and characteristic lambda max, acting like a chemical fingerprint. If you are testing a sample and you get a strong peak at 273 nanometers, you have a good clue that caffeine might be present, because that's its known lambda max. It helps you identify what's in your sample. The second, and perhaps more common reason, is for quantitative analysis, which means determining how much of a substance is present. According to the Beer-Lambert Law, absorbance is directly proportional to concentration. To get the most accurate and sensitive measurement, you want to measure at the wavelength where absorbance is highest. This is lambda max. At this peak, even a tiny change in the concentration of the substance will cause a significant, easy-to-measure change in absorbance. If you try to measure on the side of the peak, the change would be much smaller and harder to detect accurately. Think of it like tuning a radio. You turn the dial to find the frequency where the signal is the strongest and clearest. That's your lambda max. So, in summary, lambda max is the wavelength of peak absorption. It serves as a fingerprint for identifying compounds, and it is the most sensitive wavelength for measuring the concentration of a substance. I hope this breakdown makes the concept of lambda max much clearer for you. Thank you so much for watching. If this video helped you out, please show your support by liking the video, subscribing to the channel for more science content, and ringing that notification bell so you don't miss a thing. Your support is greatly appreciated and helps me continue making these videos. See you next time.